What exactly is data science? Let us try to understand it with an example. In data science, we take raw data and build value for a business. Let us explore what that value chain is. We start with raw data, also called input data or source data. Data by itself is raw. When I say raw, it means that it is in its primitive state, like a machine log or a stream of bytes or a web click event. This data is dirty. It contains inconsistent, incomplete, or unneeded events. This raw data is then converted into information that can be used purposefully. Information in raw data that is cleaned, linked with other pieces of data, transformed into its usable forms, and summarized based on time and segments. Information itself is not useful in any means. We have to use this information to generate insights about the behavior of a business. To understand information, it needs to be explored, analyzed, and modeled. This understanding results in knowledge, which can then be used to predict future outcomes of a business. Information and insights are of no use unless they are put into action. Action taken by a business to improve its future outcomes. Actions include prescriptions or strategies, cost-benefit analysis of these strategies, experiments to test the validity of these strategies, and finally deploying them in the field. Let us now walk through a simple, easy to understand example of this value addition chain. We have data about high school students and their characteristics and performance. We start off with data about students and their age. This table shows data for each student, their student ID, and their age. Next, we have the students' SAT scores. Finally, we have the students' grade point average or GPA scores. The question we are going to answer with data science here is, can a student's SAT score reliably predict a student's GPA score? This data we see here in these three tables is called raw data. Next, we convert the raw data we have into meaningful information. We have linked the three tables we saw earlier into a single table using the student ID. Now we have a data set that we can explore. Let us eyeball this table to understand if there are any patterns we can notice. Is there a pattern towards GPA? Does age impact GPA? We have students of two ages, 15 and 16, but they both seem to have the same range of GPA scores. So, there is no pattern. Next, does SAT impact GPA? A careful back and forth eyeballing will indicate that the GPA generally goes up when SAT goes up. We only have 6 rows, so we can quickly eyeball them. What if there are more than 100 rows? How do you analyze them? We have graphical charts to the rescue. We have a scatter plot for 100 students. SAT is on the x-axis and GPA is on the y-axis. You can see in general that when SAT improves, GPA also improves. The thick blue in this chart keeps moving up. To confirm, we now do another plot called as the box and whisker plot. For each GPA score, there is a box that shows the range of SAT values. The box contains the most frequent values and the lines or whiskers show the outliers. The X in middle shows the mean value. If you are still confused, I recommend reading up on this kind of plot. From the plot, you can see that the box keeps moving up as GPA increases. Each GPA score also has a range of SAT scores indicated by the tick box. In comparison, let us now do a box and whisker for age versus GPA. Here you will notice that the age remains the same irrespective of the GPA score. The boxes are one and the same, so there is no pattern here. Now that we have seen a pattern between SAT and GPA, is it possible to predict GPA from SAT? Is it possible to build a model that can be used to reliably predict GPA? We will use a machine learning technique called linear regression to plot a line through the data points. You can see the red line here. This is a model we are building in this case. This line will have a linear equation. If you have done college level math courses, you should have learned about linear equations. From this data set, the linear equation is shown as follows. The equation computes GPA as a function of the SAT score. This is the model that captures the relationship between GPA and SAT. Now, we can create an equation for any data set, but we need to know how accurate this equation is going to be. There is another metric called R2 that is used to measure the accuracy of a linear equation. From this equation, it comes about 70%. I want you now to take a deep breath and analyze how you felt going through the last few slides. Did the tables, graphs, and numbers intimidate you, or are you fairly comfortable with them? If you want to work in data science, you need to feel comfortable with data. I have seen a number of smart engineers who do not feel comfortable looking at spreadsheets and graphs. If so, data science might not be a good option for you. So, what are the insights gained from this analysis? First, we analyzed that as SAT goes up, GPA also goes up. Next, we found that age has no relation to GPA. We conclude that given an SAT score, we can predict a GPA score with an accuracy of about 70%. The action you could take on this would be to use the model to predict GPA scores of students if you know their SAT scores. This is an oversimplified example for the purpose of explaining data science to you. Real-life data science is much more complicated than this. The question I want to ask is, what if instead of just 100 rows, you have 1,000,000 rows of data and about 100 columns? You can't eyeball it. It won't load into a spreadsheet. You need to write code to analyze it. You need technology that can handle this kind of data. There is, in here, data science becomes a programming and automation driven discipline. So, let's now see the definition of data science. The first goal of data science is to extract insights from data. The next goal is to use these insights to predict future outcomes and unknowns. The final goal is to use these insights and predictions to improve business outcomes. In order to achieve these goals, data science acquires, transforms, and stores data. Accurate prediction models need huge quantities of data. Data science uses a variety of techniques and technologies from IT, statistics, and math to achieve its goals. Data science also includes the need to build and deploy these data pipelines, processing systems, prediction algorithms in a scalable and automated manner to achieve business results. Next, Let us look at some of the terminologies used in data science.